Okay, so good evening and welcome to your automated testing class in Dart. So today we'll be discussing automated testing. What is automated testing? How is it different from normal manual testing that we do? Why do you need it? When when do you need it? And why even bother at all? Okay, so automated testing. Kinika, I haven't even started and your hand is up. Okay, so why is your hand up?
Yes, please. Sorry. Sorry, I came in late. I'm seeing automated testing. Good evening, please. Sorry.
Yeah.
Are we done with Firebase?
Yes, we are done with Firebase. Is there anything you missed?
Yeah, I saw on the curriculum, I saw Firebase messaging, Firebase storage. I don't think we've done those ones.
I touched Firebase storage in our last class, and I explained Firebase messaging in our last class.
Oh, are you sure it's not that? Was it Friday? Was it Friday when network was having issues? Because I can't really recall like that. Anyway, no problem. All right. Please, and I was asking that you help me update the GitHub, like push the stuff to GitHub, but you didn't reply on Discord.
Everything that is not automated testing, let's discuss it towards the end of class, okay?
Oh, sorry. Thank you.
Okay, so automated testing. What is automated testing? Um, Automated testing is when you test your app by writing code. It tests the functionality of the application, as opposed to when you're manually testing or visually testing or using your common sense to test. Maybe clicking on a button because you programmed it to do it to behave a certain way. You now test if it actually behaves that way, right? You do this manually, you do this with your senses, okay? But there is a way you can do this with code, okay? You write code that runs against your code to test the behavior. And this is what automated testing is, right? It's mostly used in very large and complex software applications to ensure that things don't break because things can easily break sometimes. Okay, so that's automated testing. Now, because that is a language that is specifically tailored for building mobile applications. So testing in that comes in three sections. You have unit testing, you have widget testing, and you have integration testing. The only one that is specific to the language is just the unit testing. The unit testing is which is what we will deal with extensively. Unit testing is just there is no widget, there is no Flutter involved. It's just you testing components of your code. Okay. Other languages have this concept. I think in Python, unit testing is done with something called PyTest or unit test package. Okay, so unit testing is like the simplest form or unit of testing. You just test the logic you've written in your language. Okay, widget testing takes it up a notch. Widget testing, you now have to involve Flutter. Okay, test the widgets we build, test the interactions we build. When you click a button, does something change? Does a part of the UI change to reflect? You write all these things with test. Okay, and integration tests takes it up a notch to test the whole application. Okay, kind of simulates the interactions visually for you. But unit testing, which is the one we'll be dealing with extensively. What is it? How is it? How do you get started? When do you need it, right? So most often, when you're writing your controllers or repositories, you might want to write tests that check if they behave a certain way, or want to write tests that will ensure that any minute errors or small things that happen can be caught easily, because that's another function of tests, right? Once your program is extensively tested and documented, anytime you make a push and the test runs and something breaks, you easily find it out. Okay, as opposed to when you don't have any tests on that application, you might find out errors in runtime or production, which is not ideal, right? Okay, so why and when do we need automated testing? And why, when, and where do you need automated testing? I've explained a bit of the why. Okay. Okay. When? Well, when is anytime, actually. Anytime. Sometimes you're working in a company, a highly technical company or software company, their workflow, you have workflows for testing. You must always write tests before you make a push or pull. Okay. So that's when. Okay, so where do you write tests? For unit tests, basically in that you put it in a folder called tests. Okay, this is different from your actual source code, which is most times, mainly, well, not most times, almost all the time, stored in the lib folder. Your source code is stored in the lib folder, but your test code is stored in the test folder. These are on the same level. Okay, you have the lib and you have the test. This just shows that the test is not part of the program. It's just something that you do during development, right? Okay, so that's where you put your test in the test folder. Okay. So essentially in that there are two packages that I've been needing to write tests. The first one is the test package, as the name implies, test. Second one is Flutter test, right? What test package does is it's kind of a building block for Flutter test. Flutter test incorporates the normal test package and adds a little bit of sugar to enable you to do widget testing and integration testing if you're building mobile applications, right? But the test is what you'll be using for unit tests, okay? So basically, the structure of a test, tests are structured into things called test cases, okay? I think most other languages have the same concept, test cases, where you test a particular unit of your program. You write a test case, with a description, label, or something that describes what the test should do. Write a test case. You can have like 1, 2, 3, 4, 5, 6 test cases. Okay. And then you have the code inside it that checks against the result of your program. We'll be looking at of that very soon, right? But that offers us another level of organization, something called grouping. You can group your test cases into a particular group. So you can have multiple groups of test cases like that. For instance, you want to write tests for a controller, and each test case tests a particular method of that controller. You can group it under the name of your controller class. You can name the group maybe uh my authentication controller, something. You group it like that, and we group other things like that. So that's the structure of the test. Okay, so we're looking at some examples. How do you get started? So my VS Code should be open. Okay. So I already prepared some example, but so as not to overwhelm you, we'll take it from scratch for now. Okay, so note, like I explained before, you have your lib and you have your test folder. I'm sure most of you have seen this test folder. You may have wondered what is inside it. Why does it even exist? So most times when you create a new Flutter project, it comes with the default widget.test, and that's this thing we are seeing here, right? This is the default widget testing. I'm just going to comment this out. You can see the file is named widget_test. This is something quite important that I should note, right? There's something called a test discovery. You use the command line most times to run your tests. But if you have an IDE that supports you just clicking and dragging, you can also use the IDE to run tests. But for the sake of this class, we'll be using the command line, right? And there's something called test discovery. Basically, it goes into your project, your source code, and discovers the files that are test files. Okay. But test files are different from your source code. Okay, so the test discovery needs to know how to identify a file that is a test file. Okay, so that's why it has to be suffixed with the text keyword. So you can see in this test folder, the first test file we have is widget test, which Flutter gives us by default. We suffix with test, and the other ones I created, I named them and I suffix them with test. You have example test, unit test. So basically, if you don't suffix or you suffix incorrectly or the suffix is not there, your test file is not going to be discovered. And what that means is test is not going to run. So that's something important to know for us before we start to going into testing. Okay. So we'll be looking at unit testing. Okay. I'll be programmatically showing you the structure of a unit test. Sorry, please confirm you can hear me.
Yes, we can.
I can hear you.
Okay. Okay, so yes, unit testing. So we have an empty Dart file. First thing you should do is import your test package. Remember I said you need to have a test package. Test package is like the base package that provides all the functionality that we need to write test package. Most times if you have Flutter installed, Flutter comes with Flutter test, and Flutter test includes the test package as a transitive dependency. Okay. So, but I already installed the test package, so I can do this package test slash dart. Okay. And your test files, for every test file you write that is runnable, it needs to have a main function. Sure, we know what main function is, the entry point of your program. So the test files need to have a main function. It's inside this main function that you'll be writing your tests, grouping them accordingly. So let's take a very simple example just to explain the structure of a unit test. Okay. Say I have a simple alt controller. Let's just take this out now. A simple alt controller, right? What does an alt controller do for us? Alt controller enables us to sign in a user, right? So you need to be able to test that when maybe a password is correct, a user is correctly signed in, and we have the verification credentials or whatever we need, right? You can write tests against this simple functionality. Oh, please give me a minute.
Yeah, please, are you speaking or because for myself, I can't hear anything. I don't know what others.
Apologies. Sorry. Yes, I was speaking. So I'm setting up this basic authentication controller, right? So this authentication controller, what it's going to do for us is it's going to hold access token for when our user is signed in. Okay, so you can see we have a basic definition here, just an access token. It's logged in is when access token is not null, right? Okay, so we have a single sign-in method. Okay, and when this method, when it's complete, let's say for test purposes, let's just define a test. Just name this correct email for test purposes. We have correct email and correct password. So basically, this mock sign-in method is just going to check if email is equal to correct email and email is equal to and password is correct is equal to the correct password, and it gives us a mock access token, right? So let's do the implementation real quick. So how do we test? Now we have this basic controller for signing in. How do we test it? How do we write the test to check if the logic is correct? Okay, first of all, you need to understand what you are testing against. The unit you want to test. Now, the unit you want to test here is this sign method, right? You want to test if it actually works the way it is intended to work. Okay, so first of all, ask ourselves, what does this signing method do? Look at the implementation. So it takes our email and password, right? And it checks if they are correct, like a typical signing method would do. Checks if they are correct. If it's correct, it gives us an access token that we can store and use this access token however we see fit. Okay, so now keeping that in mind, now let's write the test. To write a test, basically, that is very, very intuitive. You just use the test function from inside this package and you pass it a description. You can see it says here description and body. So description is a string and body is a function, a method, or a callback, or a closure. They are all the same thing. Any callable can be passed inside this body. So the description is where you put the description of that particular test you want to test. Okay. So we want to test, remember we want to test our signing method, right? And to see if it correctly signs in. So this is where you enter the description. And you want, just make it descriptive of what you're testing so that when you're seeing the test logs, you can clearly identify what failed and what passed, right? So, and I said body is a closure. Let me open up the overall documentation of this. You can see this is the signature of this function, right? And see body is of type function, okay, and it has other types too, okay. So inside this body is where you define your tests, okay. How do you define our test? First of all, we create an instance of the controller, okay, and now we test the signing method, controller dot signing. Now we give it an email. That's Ngozi at gmail.com. And we give it an obviously wrong password. Now, after calling this method, right, it's expected that if everything goes well, its login is supposed to be true, right? So how do we check against that value that is going to be true? That's using something called expect. Okay, so this is very, 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 very important. So some languages use something, other things. For instance, Python uses assert statement inside their test cases. Okay, but in that you use expect. This is where you put the actual checking of the result of your code. Okay, so basically what this means is it takes two parameters, actual and matcher. Okay, actual is the actual result you want to check against, and matcher is, well, matcher is a little bit complex. Okay, because matcher can be many things, right? There are many matchers actually, but let's just start simple for now. So actual is the actual result of the program, and matcher is what you want to use to check against the result, the actual result. Okay, it kind of works like a comparison something. So let me just continue with the example. I think you understand it better now. So you want to check if it's logged in is true after we've called this controller.signin method, right? So how do we do that? The actual result is controller dot is logged in, right? Okay, and we want to check if equals true. So this is how you do it. Just give some space there. So now, how do we run this test? Okay, we've written a very, very basic test case. How do we run this test? There are two ways, but I prefer to use the terminal always. So open up your terminal and you run the command dart test. Now, what this command does is starts off the test discovery. Test discovery goes into your source code. That's everything inside this your working directory. Okay, and specifically the test folder if it's available, and it looks for any files suffixed with test. Okay, So let's run this command. Let's see what happens in the bits. Okay. Okay, so it says some tests failed. Yeah, and that's inside our example test.target. I think the other tests in this package, let me just comment them out. Okay, let's run that again. So now we know it's just running example.test. Okay, so it says there's some tests failed. So let's try to find out why the tests failed. So because we're expecting this login to be true, but this is obviously false, because remember in the implementation of the method, we are saying if this is equal to this, then give us an access token, which states if you are logged in or not. So that means this test should actually check that this user is logged in with the wrong password and email, and therefore should be false. So let's correct that. Okay. Okay, so here it says error loading tests. Okay, so we don't want it to load this widget test. Let's delete this real quick. Okay, good. So so see what's happening there, right? I think it was reading these other files that we didn't want it to read. We wanted it to only test example, test everything inside the example test.dat file. Okay, so I just had to move those other ones out. Okay, so you can see the test passes. Now let's analyze quickly. Why is this test passing? In this test pass, remember we say here if email equal to correct email and password, yada yada yada. It was test access token, right? And this is logged in, just basically checks if access token is not null, which states that we are logged in, right? Because and we obviously entered the wrong email and password. That means we're expecting that if you enter the wrong email and password, we're expecting is logged in to be false. That means we are not expecting to be logged in. Basically, that's what this means, right? So that's why our test is passing. So so we can name this description test or controller sign-in fails with incorrect password. So I think with this you understand the basic structure of the unit tests, right? So now how do we actually test for the positive case? As if everything goes well, how do we test that it actually goes well? So we can say we can duplicate this. We can duplicate this. Can actually put it inside here too, but just to make sure you separate things, know the one that is filling and the one that is passing. You can create another test case. A test case is simply just this. If you put it inside the test function, the test case, that treats it as a test case. You can create another test case and just name it, tests or controller dot sign in passes with correct password. Okay, so let's just copy over this. Okay, good. So now we're going to give it the correct password and we hope that it passes. So the correct password is, correct email is my email. Correct password is my password. Okay, so we run this test again using the command dart. Sorry, that test, not text. Dart test. Okay, beautiful. All tests pass. No, no, no. All tests are not supposed to pass. Okay, so we entered the wrong password again. So this is the correct password, password 123. So we just entered it. Oh, that was an oversight. And this is supposed to be equals to true because now we are entering the correct email and password. So we are expecting to be logged in. So we are expecting is logged in to be true. Okay, and we're using this matcher. This you can see when I hover over the documentation of this equals, you can see that it's a type. It gives you a matcher, okay, which is what this expect parameter expects. Well, here it says dynamic, right? Because it needs to be more flexible. The reason it says dynamic is because instead of using this equals, you can just place this with false or true or any actual value. It just tests against it. But why you need matcher is for more advanced use cases. For instance, well, we'll get to that. For now, let's just focus on this. Okay, so we see our test is failing. So let's look at the logs and see why our test is failing. Okay, so let's analyze the logs and understand what's going on here because when you're writing tests, you'll be seeing this a lot. So it says test alt controller sign-in passes with correct password. That is the description we entered. You can see the expected value, the actual value that we're testing against, which is this controller that is logged in. We are expecting it to be true, but it is actually false. Okay, so that means there's something wrong in our program. And this is what tests help you discover, helps you discover what is wrong in your program. Right? Because now we are given the correct email and password supposedly. Okay, so we expect to be logged in. So Ginika, your hand is up.
Yes, please. I was hoping whether you can maybe copy that your former password and paste it. What if there was error in the spelling of your Gmail? Like, have you
Sorry,
checked?
come again.
Like
Come again.
the Collins X Nana, have you checked that maybe there was no error in any of them that is mismatching?
Okay, so I think that's what we do. I'm trying to find out the error in our program. We will do that. So I already copied out the password as password 123. And I think I wrote down the same email because it's my email and I remember it by head. So what is wrong with our program? Okay. So let me do what Kinika just said now. I'll just copy over this email address, this supposedly correct email address, and I'll put it here. Okay, so hopefully this should work now. If it doesn't work, means there's something wrong in our program and we need to fix it. Oh, okay, wonderful. Seems Ginika, you were right. Seems you were right. So there was probably something wrong with the password I entered. So now the test is passing, as you can see. So this is the basic structure of so this is the basic structure of a unit test. Okay. You have your main function and you have your different test cases. You have our first test case, and you have our second test case. You can see my IDE, but my IDE has Flutter extensions and that extension installed. It kind of shows me this quick action button like run, debug. So you can also run this through the IDE. So though it takes time, and that's why I prefer the command line. Running things through the IDE sometimes can take time, and most of the times you might not understand what is actually going on. So that's just one of the things you can do, right? So let's move over to more advanced test cases. Okay, beautiful. So you can see the IDE later responded after 10 years. Okay. So because we clicked on just one test case, it ran just that one test case for us. So this is especially useful when you don't want to run the whole test, because sometimes when you have lots of tests in your program, you might just want to quickly run one and see what that one does. You don't have to run everything, so you can quickly do this in IDE. Just go over the test case and just click on run. Okay. So yeah, that's simple basic test structure, right? Okay. So let's discuss matchers real quick. Matchers real quick. Okay. Like I explained before, though not in detail, matchers are what actually checks the result of what you want to test. The basic idea of testing is that you have something you want to test or check the validity. That's the idea. So you have the actual and you have the expected. So that has this concept of matchers. Okay, like you can see, I'm using the equals matcher, like the name suggests. Let's take a look at the documentation here. It says it returns a matcher that matches if the value is structurally equal to expected. Okay, very simple, as the name suggests. Okay, but there are um other much more advanced matchers. Matchers that let you check the values in a list. Okay, or matchers that do much more complex things. Okay, we'll be looking at some of the examples. Hmm, okay. Sorry, I'm back. So yes, let's discuss matchers a bit, right? We have simple matchers like equals, like we've seen. equals, like we've seen. We have equals. Let's just go through them one after the other. We have equals. We have, I think, is null. Okay, is null. Okay, this one is not a function that returns the matcher. It's the actual matcher itself. Okay, we have is not null. Okay, we have less than, greater than. We have less than. You can always check this in your VS Code, right? We have is empty. Is empty. Okay, good. You can see it. Is not empty. These are for collections. Right? So you want to test that some value, want to test the functionality of a collection they're using in your program. Right? So you can use this, it's not empty, it's empty. And like their name suggests, they're quite intuitive to use, like, right? So you see this equals, the way we just use it, we just pass the value that we want to check if it's equal to in our test case, right? Okay. So for instance, let's say you want to test the collection. Okay. Let's comment this out. Let's use the post controller just to make life easier. You have a simple collection, a list of, well, let's call it products. Okay. So basically, initially, this list of products, we're expecting it to be empty, right? And we have a method called fetch product. So this method is what's going to populate our product, right? And we're written the program, like this hypothetical program, and we want to make sure that every time fetch product is run, it actually populates our product list. Maybe we are going to be using this product list in our view, maybe a screen that just kind of draws the products on the screen and does all that, right? So we want to test this fetch products method to ensure that it actually does what it's supposed to do, populate product for us. So these fetch products might, go to the internet or go to some service and get it however it wants to get it. That's not our concern right now. All right, so let's just quickly build that's add all list dot field. Let's just add just 5 products. Okay. So now we want to test this collection, this functionality, this fetch products method. So how do we do that? First of all, to test, you have to understand what you're testing for. And I've explained this before. Look at the method you're testing for. When you want to test rather. What does it do? Okay. When you understand what it does, that's when you understand how to write your test case. And of course, yes, there are very, very complex methods that maybe one test case might not cover, right? But for this example, this is a very, very simple method. It just adds something to the products list. So let's duplicate this minutes. Show you how to test collections. Here's that controller version products relate the products database. Okay. So here we have our instance, right? So first of all, we call the method we want to test against. The name of the method is called fetch products. Okay. So now we've called it, the program has done its part. Now this is the part for the test. for the test case to do. We now want to check if the items in the products, sorry, we now want to check if products is really not empty after calling fetch products. So this is how you do it. You pass in controller of product. This is the thing you want to check against, right? And now you give it a matcher. Okay. Remember, I talked about matcher before this example. I said what match was. I explained what matcher does, right? It checks against your actual value. So we have a quick matcher that gives us it's not empty. Okay, and that's what we're going to use. So if I hover over it real quick, you see that the type is of type matcher. Okay, so basically it's going to expect that this product list is not empty. That calling fetch product. So if we run this test, all things being equal, all things should go well. Okay, good. So you can see that all tests pass, right? That means what this thing means now is that our fetch products method is working as it should. That means everything is good, right? Okay. So yeah, that's the it's not empty matcher. There are other matchers that you can use depending on your use case and what you need to do. Okay. And I mentioned something about grouping. How do you group your tests into recognizable units? Like say, maybe I have another controller that I want to test, maybe product controller, or I have three controllers. Say, how do I group them? That I know which one is failing, I know which one is passing. I just want to organize them. How do we do that? So there's something called a group. Okay, so you use the group method. At this point, I know you'll be wondering, not wondering, but you must be saying that is so intuitive. Yeah, that's how that is. You want to group, use the group method. You want to test, use the test method. You don't have to overthink it like other languages. So yeah, you use the group method. So because maybe we have another controller, let me just copy this over to make life easy. And name this a cart controller. All this is not needed in our cart control. There's a carts. Very simple. Let's use the generate now. It's very distinguish between them. Let's just name this update cart. So we want to test this method, right? That is in our code base. We also want to test this. So far, we've seen how to test just one example, but because in your program, you're going to have like multiple things that you want to test, right? And you need to be able to group them. Okay. So how do you do that? Inside your main test function, you use a group keyword, right? So what this does is means in this first group, let's say it's the class computer I want to test first. Then I'll give the description. Maybe just name it cart. Okay, so every test for this class controller is going to go inside this method. Okay, and we have another group called auth controller. So every test for the auth controller is going to go inside this. All right, so now let's copy over tests we've written so far. So we copy them and we dump them inside the auth controller. Okay, and now we have our cart controller. So let's write one test case for the cart, which tests the update product method inside our cart controller. So we just give the simple description. With an instance. Cards. And now we write our expect, okay? Very simple test, okay? So you can see now we have like visually distinct groups of tests, right? And when any test fails, they're going to see it and know the one that is failing. It helps you to actually organize it better. Okay, let's simulate failing tests. Let's uncomment this first. Okay, good. So one of our test fails, which we expected, right? Okay, so you can see here it tells us alt controller, which is the group. You can see it here in the test log. You can see, let me highlight it. You can see alt controller, which is the group. Okay, and you can now see the description of the actual test case is the one that is failing. Okay, so this is how to group tests. This is how to group tests together, right? So sometimes you might have some objects. Sometimes you might have some objects, right? That you don't want to be creating an instance of them in every test case. Or maybe you want to reuse them across multiple test cases. They don't want to have to be instantiating them every time you want test case, right? Uh, let's take a look at this example we have here. This auth controller, you can see in every of the test cases, we are instantiating auth controller, right? Here we instantiate auth controller because we want test against it. But sometimes your use cases, this might not be so feasible because you may want to carry over some things from the previous test into the next test, right? So that provides us a way to do this using something called setup and tear down, right? It just enables you instantiate whatever you need outside the test and kind of reuse it. Okay. So how would you do that now? We just come here and write the first of all, you have to move this out of here first. Late. I don't know what we use late for. When you expect something to instantiate late, just use the late keyword, unless that is gonna throw you an error. So this auto controller that we have, we are going to be reusing it in each of these test cases. We don't want to be instantiating it inside these test cases manually. So we use something called setup. Okay, so look at the documentation for a bit. We have the first one is setup, and let's look at what it says, right? It says it registers a function to be run before test. So this function will be called before each test is run, right? So that means any function we pass into this setup is going to be run. Let me explain, right? Any function we pass into this test is going to be run before test 1 is run, test 2 is run, the function will be run again. Before test 3 is run, this function, this this setup function is going to run again. But if we use something called setup all, it's just going to run once, right? So based on this I've explained now, we need just, I didn't ask you to, we need just we need the function that only runs one and creates an instance of the controller for us. That means we need the setup all. Okay. So register function. Now what this function does is it just creates an instance of auth controller. Okay. So what will happen now is that we don't need to call this instantiation again in our test methods, because it's created outside our tests. And this is very, very useful when you want to use things outside the test. You don't want to create instances of them. Okay. So the idea is, before this test is run, the controller is instantiated once. Okay. After running, the controller is still there. It is not disposed. So this test can also use it, and this test can also use it. Okay. So that's how to do that. We run this example. Everything should work. Okay, beautiful. So you can see we are creating an instance of the controller here. We don't have to define it multiple times in each of the test methods. So that's how to do that, right? Sometimes you might have side effects or things that you might want to do before you start running your test, and that's why you use the setup method. Okay. So there's an equivalent tear down, right? So let's look at the documentation real quick. You can see here it says register a function to be run after tests, and they have tear down all. Register a function to be run once after all tests, right? So you might have a very complex test that, maybe when you finish running it, maybe you might have provisioned some things on your system to run it. Like, for instance, set up a local database or something. They want to free up the resources after running the test. So this is where you put that whole logic, tear down and tear down all. Okay, like the name suggests, so the first one runs every time after each test, and the second one runs only once after all the tests are complete, right? So this is a bit about unit tests. In our next class, we'll be looking at something called mocking. Mocking, right? How to mock your unit tests. And I'll be explaining what mocking is and how and when you need to use it. Okay, so for this class, we've seen basic example just to demonstrate how testing works. I also prepared some examples on this repository that I'll be uploading to the repository, so that you can go and take a look at it yourself and study it yourself and understand. So that's this unit test that file. So I'll upload that today. You can always go and check it out. So if anyone has any question, this is the time to ask. Yes, go ahead with your question.
All right. I want to understand something, please. How do we let's say I have sign in function or even these fetch products in my main lib folder, my application. Like, how do I know that that one I wrote is correct? Is it that I'll come and write another one here, or I will take that same method and come and put here on my test and test it?
Okay, very, very, very wonderful example, right? So let's see how that works in a minute. So we have something in our lib folder, that's our actual program folder that we want to test. Okay, so basically the same thing. This is basically the same thing. I can just move all this to this folder, to this file, and this file is located inside our lib folder, our library folder, right? So all you have to do is it's not here anymore. What you have to do is just simply import. Just a matter of import statement. So you can see I've imported it from the lib folder. So does that answer your question?
Okay, yes, thank you very much. Okay, I was just thinking. So these are we'll be doing all of them, right?
Yes,
And is
exactly.
it only functions that is tested in unit testing, just our functions?
They are very complex. Let me just say this. Your test case, that's this thing, can be as complex as you want it to be. Programs can be complex, right? You might have things that maybe a complex program that maybe checks the weather and updates an AI system that, provides push notifications to you, whatever it is, right? But the idea is that you want to be able to test one feature or one particular unit to ensure that it works as it's supposed to be, as it's supposed to work, rather. So you put that here and you test it. Okay, so anything you want, you can test. Does that answer your question?
Yes, it does. Thank you.
So, if there are no other questions, I think we would call it a wrap. Call it a wrap today.
Okay, please, sorry. Please, will you push this one now to Git Hub also?
Yes, okay, yeah. The last one I pushed it a little bit late, and I apologize for that one, right? But yeah, this code is going to be live just after this class, and all the examples inside it, so you can study yourself.
All right, thank you very much.
Okay. So like I said, in our next class, we'll be looking at mocking. What is mocking? You can also go and do some research for yourself, find out about mocking, when and how you use it. Okay. So thank you very much for joining this class. I hope to see you in the next one.